Hello, this is a demo of the application which combines two different CNN models or same CNN model with different parameters. So I'll quickly turn on the server and we'll have a quick look at the UI and come back to the code to view what exactly is happening. So I'm here starting the server. So it opens up a web application. So in this web application, if you see, we have an option to choose between the comparison parameters. So as I was saying, this example will show the same model being trained on different parameters. Out of when I say different, there are four different parameters which I have chosen for this example. One is the number of output channels, the optimizer, whether it is Adam or SGD, the batch size, two models, one with 32 and one with 128, and number of epochs in which the training is being done. For this example, I have taken model 1 for 3 epochs and model 2 as 4 epochs. So I'll just choose one of the parameter over here. Let's choose optimizer for this example and start the training. So while it is getting trained, as you can see, there are four different graphs, one for model 1 and the rest for model 2. For each model we are showing what is the loss and what is the accuracy and how it is been reducing or increasing over the as the training progresses and all the epochs are being closed. So the same is being reflected in the logs as well, as you can see over here. So this shows what parameter we have chosen, the number of parameters in each model, and we are now seeing that model 1 is getting trained on 3 epochs, right? So here it shows the progress of each epoch and also shows what is the loss and accuracy at the end of each epoch. So while it is getting trained, while both the models are getting trained, let's have a quick look at how it is done. So this is typically a Flask application. So in the Flask application, we are taking the input from the front end, and the model is defined as a CNN model. So again, the base of this project is basically to train a model on MNIST data, which is handwritten data, handwritten alphabets data, and try to predict with some with some with some of the images which the system takes automatically and show the results. So this is an MNIST model which has a series of convolution layers, and they get it gets trained or on these layers, and the results are based on this model, right? So this is how train.py is basically where the training is happening. As you can see, we have the train data and the test data, which is again being used from MNIST. And when we have the actual train models method is written in such a way that depending on the parameter, depending on the comparison parameter which the user chooses, we are defining what type of output layers we want, what type of an optimizer we want, what should be the batch size, and what should be the number of epochs. So for this example, as we have selected epochs, all the things remain same except for the epochs. As you can see, model 1 is getting trained on 3 epochs, and model 2 is getting trained for 4 epochs. All the other things remain same. So even similar thing for the batch size. So once the training is done for all the epochs, we can see the logs. As we can see the logs over here, the same is being reflected on the graphs as well. So the current log says it is running epoch 2 of 3 of model 2. So we can see the training for model 1 is done. Now we can see the logs over here. We can see the the parameters or the values on this graph, and similarly the rest of the parameters for model 2 will also be displayed over here in as and when it finishes training. So we are in the second epoch. Now we go to the third epoch, and as we can see, the graph is being updated real time whenever an epoch is finished. Let's just wait till the third epoch is finished, and we can go and check the predictions based on these parameters. Yeah, now that now that all the training is done, all the epochs, three epochs for model 1 and three epochs for model 2 are done. So you can see here the predictions are also being generated, so 10 each for the model. Now if you have to go and check the results, you just have to tap on this results, and both the models are more or less giving us exact results. So 10 images out of 10 images, 10 images are correct. Even the same for the model 2, right? So this helps us in comparing two different models. So this approach will help us in comparing two different models or the same model with different parameters, etc., etc. So at different levels, like we can track how the model is getting trained over a period of epochs, right? It will be helpful probably in training the real time, not with the simple training data like the MNIST one, but whenever we are training with some real time data, probably we can read those logs in between the logs and probably compare the graphs on different parameters, which will help us in getting the model to predict or to work in a better way. So that's all for this demonstration. Thank you.